For any help regarding magnetic materials assignment help, visit https://www.eduassignmenthelp.com. Email info@eduassignmenthelp.com. Call us at +1 678 648 4277. 1. Show that the magnetostriction constants of Fe and Ni are not of the sign you would expect for dipole forces between atomic bar dipole magnets. 2. Consider a bar of iron with 110 along its length and the top surface is 001. It is under tensile stress along its length. 100 equals 20.5 10 to 6, 111 equals minus 21.5 10 to 6, C equals 2.4 1011, 11 C 11, 11 2 12 is equal to 1.4 10 C 44 equals 1.2 10 N/M. A. Write the strain tensor in the bar coordinates and in the crystallographic coordinates. B. Which terms in EQ 7.9 are relevant to the effects of stress on the orientation of M? C. If the stress is such as to produce a strain E of 0.1%, compare the magnitude of the magnetoelastic and magnetocrystalline anisotropy. D. Evaluate the appropriate energy terms to determine the direction of M at E equals 0.01. E. Derive the equation of motion of the magnetization as a function of field and strain. Plot MH for E equals 0 and E equals 1%. Qualitatively describe your results. eduassignmenthelp.com. 3. Derive X. 7.7. The equilibrium strains from X. 7.6. 4. Show that setting 111 equals 100 equals S in EQ 7.16 gives EQ 7.17. 7.5. Consider a thin epitaxial Ni film on Cu 100, Ni equals 3.524 A, ACU equals 3.615 A. Assume for Ni 100 equals minus 46 10 to 6, C equals 2.5 1011, C equals 1.6 1011 and C equals 1.18 1011 11 12 44. N/M2A. Compare the relative strength of crystal anisotropy, magnetoelastic anisotropy, and magnetostatic energy as far as determining the direction of MB. Assume E0. Find the equilibrium direction of M in zero field and for small Ni12. Thickness. C. As the film grows, describe what happens to E, Ij. IJD. If E equals 2E, find the direction of M, 1211. eduassignmenthelp.com. Discuss. 7.6 Show that the two alternate ways of defining the magnetoelastic coefficients, X. 7.8 and 7.34, are equivalent. How are the BS and BS related? 7.7. It has been written in a technical article. Typically, magnetic transition metals produce magnetostrictive strains E, at saturation, of order 10 to 5 to 10 to 4 which vary about the direction of magnetization roughly as E equals 3/2 S, cos 2 1/3, where S is the saturation magnetostriction constant. Conversely, stresses imposed on the material which result in strains of order 10 to 5 to 10 to 4, i.e. E equals S, contribute significantly to the total magnetic anisotropy. The uniaxial stress-induced anisotropy energy density is 3/2 S. Critique these statements by considering the energy densities in each case. 7.8 Use EQ 7.10 to describe the field and strain directions you would use to measure the two magnetostriction constants 100 and 111 on a Ni sample cut as shown in Figure 7.3. Do not assume that the sample has randomly distributed magnetization directions in zero field. 7.9. Assume a multi-domain polycrystalline sample with the domain magnetizations randomly oriented as represented below. eduassignmenthelp.com Describe how you would expect the magnetization distribution to change if the sample has positive magnetostriction S and a tensile stress XX is applied for H equals 0. Contrast this with the change caused by application of H equals HO 0 0 for IJ equals 0. Plot MX versus HX for XX equals 0 and XX 0. Plot MX versus XX for applied fields in the range HX-HK. 7.10. Consider the anisotropy constants, K1, and the polycrystalline magnetostriction constants, S, shown below for FCC Ni-Fe alloys. This problem is about the behavior of alloys having compositions A, B and C. Sketch and label the lowest order crystal-crystal anisotropy surfaces in the XY plane for thin films of compositions A and C, i.e. assume Z equals 0. 4 unstrained bulk samples of compositions A, B and C, in which crystallographic directions are the samples easily magnetized. C.4 unstrained single crystal samples A, B and C, a field is applied in the 100 direction. Sketch the shape of the MH curve in each case assuming zero coercivity. Use approximately the same field scale in each case so the MH curves can be compared. eduassignmenthelp.com. E. For single crystal samples A, B and C, apply a field in the 100 direction as in part C above, but now also put the sample under tensile stress parallel to the field direction. Sketch with a dashed line over your result in C, the shape of the strained MH curve in each case assuming zero coercivity. F. What is the approximate value of the magnetoelastic coupling coefficient, B1, for sample B? If a strain is applied along 100, to cancel the crystal anisotropy in this. A. If the samples are subject to strains, which composition, A, B or C, would make the best soft magnetic material? Y. Sample B? If a strain is applied along 100, to cancel the crystal anisotropy in this sample and have the magnetization lie along the x-axis in zero field, what would be the nature of that strain, tensile or compressive along 100, and what is its approximate magnitude? 7.1 The potential energy of two dipoles, M at the origin and M a distance r away, is given by X. 1.9 and 1.8. When ferromagnets are of interest, the two dipoles have the same orientation and the second dipole moment can be expressed in polar coordinates of its position as m equals m, cos sin EO. The radial force between the two dipoles, now m equals m, is given by eduassignmenthelp.com. F is attractive for collinear moments, equals 0, and repulsive for side-by-side moments, equals /2. Thus one would expect strain E10 for any direction of magnetization and E20 perpendicular to any direction of magnetization. Applying equation 9.1 to these dipole strains implies S0. But Fe and Ni have very different S in different directions and 100 for iron is positive not negative. 3. The 6x. 7.6 contains 6 unknowns, the Ij. The coefficients Sig and constants B1I2 and B2Ij are assumed known. Solve the first 3 for Ij, I equals j, and the last 3 for Ij, Ij, to get EQ 7.7. 4. EQ 7.16 then gives eduassignmenthelp.com. Since the principal axes are no longer tied to the crystal, which is isotropic, the coordinates can be rotated so that the z-axis coincides with the direction in which the strain is measured. Then only one direction cosine survives, 3,2 equals cos 2, whereas the angle between m and the strain direction. 7.5 Misfit, ACU on E/ACU is equals 2.5% from lattice constants given. A, K1 equals minus 4.5103J/M3 and from EQ 7.20, B1 equals dash 3 halves 100 C11 C12 equals 6.2106N/M2. For a biaxial misfit strain, the tensor components are eduassignmenthelp.com